Welcome learners. The objective of this video lecture is to derive Newton's backward formula and to solve a problem by using Newton's backward interpolation formula. For applying Newton's backward formula, the values to be interpolated must be at the end of the given set of observations. The conditions for applying Newton backward formula is the arguments x must be at the equal interval h, and let the paired values be x0, y0, x1, yn up to xn, yn, and the function y is equal to f of x is a polynomial approximated by the nth degree polynomial. We assume the polynomial Pnx in the following form: y is equal to f of x is equal to a0 plus a1 x minus xn plus a2 into x minus xn minus 1, so on. The last term is an minus 1, so on, x minus x1. Let us assume that this is equation 1. Our objective is to determine the coefficient terms a0, a1 and an first, and substituting these coefficients to get Newton backward interpolation formula. Our goal is to find the constant such that the curve passes through all these n plus 1 points. Here we have n plus 1 points. A0 to an is n plus 1 points. So our objective is to determine the constants first. Substitute x is equal to xn in equation 1. X is equal to xn. Here this is equal to y f of xn, that is yn is equal to a1 into xn minus xn becomes 0. Second term also 0. So except a0, the remaining terms became 0. So yn is equal to a0. Simply the coefficient a0 is equal to yn. Substitute x is equal to xn minus 1 in equation 1. Two terms remains. The remaining terms became 0. So yn minus 1 is equal to a0 plus a1 into xn minus 1 minus xn. Since xn minus xn minus 1, these are equidistant arguments, xn minus xn minus 1 is equal to h, then the reverse, xn minus 1 minus xn is equal to minus h. So yn minus 1 is equal to a0 is equal to yn plus a1 into minus h. This is, we need a1 only, so a1 is equal to yn minus yn minus 1 divided by h. Since this a1 minus h comes here, this becomes positive. So plus a1 is equal to yn minus 1 divided by h. We know that from the operator nebula yn is equal to yn minus 1. So we can use the numerator as nebula yn divided by h. So the second coefficient a1 is equal to nebula yn by 1 factorial into h. Substitute x is equal to xn minus 2 in equation 1. Note that xn minus 2 minus xn is the 2 times of the interval. Because we are subtracting from xn minus 2, it is minus 2h. Similarly, xn minus 2 minus xn minus 1, it is minus h. Now by substituting except 3 terms, the remaining terms gets cancelled from here onwards. From here onwards, xn minus 2, a3, a2 remains, a3 onwards became 0. So yn minus 2 is equal to a0 plus a1 into minus 2h, xn minus 2 minus xn minus 2h plus a2 into x n minus 2 into xn minus 1, xn minus 2 into xn minus 2 minus xn, xn minus 2 minus xn minus 1. So this is minus h, this is minus 2h. Yn minus 2 is equal to, instead of a0, we can write yn. Instead of a1, we write yn minus 1 divided by h into minus 2h plus minus of minus plus h into h square 2h square a2. Here yn minus 2 is equal to yn minus 2 into yn minus of minus plus 2 into yn minus 1 plus 2h square a2. Look here. Here we have substitute the LHS and RHS with minus 1. So the minus 2n minus yn becomes minus yn. We are multiplying throughout with minus 1. So this minus comes in the left hand side. This became plus minus 2h square a2 became 2h square a2, and here this yn minus 2yn plus yn minus yn becomes, we are multiplying with minus 1, this yn minus 2yn minus 1 plus yn minus 2 comes into right hand side. So the simplification is this. Using the identity nebula square yn is equal to yn minus 2yn minus 1 plus yn minus 2. Since nebula square yn is equal to nebula yn minus nebula yn minus 1, we know that nebula yn is equal to yn minus 1 and nebula yn minus 1 is equal to yn minus 1 minus yn minus 2. So we can use this identity. So the a2 is equal to, we can use nebula square yn instead of this expression, nebula square yn by 2 factorial into h square. This is our equation 3. By continuing this process for substituting x is equal to n minus xn minus 3, xn minus 4, so on, last term x is equal to x0, we obtain a3 is equal to nebula cube yn by 3 factorial into h cube, so on, an is equal to nebula power n yn by n factorial into h power n. Assume that this is equation 4. Substituting equation 2, 3 and 4 and a0 values into the main polynomial x1, instead of a0, yn, this is a1, a2 and so on, this is an. This is our fifth polynomial, fifth equation. Let u is equal to x minus xn by h. This implies this h multiplies u, x minus xn is equal to uh, x minus xn minus h. We know that xn minus 1 is equal to xn minus 1. So we can use, instead of xn minus 1, xn minus 1 interval, xn minus h. So x minus of minus h is equal to plus, we can write this as x minus xn plus h. Since this difference is, we can use, instead of xn minus 1, we can use xn minus h. So x minus xn is equal to uh. So this is uh plus h. by commoning h, we can get u plus 1 into h. Similarly, x minus xn minus 2 is u plus 2 by h. So the terms becomes multiplying these two terms x minus xn into x minus xn minus 1 is equal to uh into u plus 1 into h. So this is u into u plus 1 h square, the multiplication of these two terms. Similarly, x minus xn up to x minus xn minus k minus 1. Let us assume k minus 1 is equal to u into u plus 1, so on, u plus k minus 1 into h power k. Substituting these u relations into the equation, we get the standard Newton backward formula as yx is equal to yn plus u into nebula yn plus u into u plus 1 by 2 factorial into nebula square yn, so on. For better understanding, here u is equal to x minus xn by h. For better understanding, let us discuss an example. First, the x values are equidistance values 10 to 50, and y values are for 10 it is 46, and for 50 it is 101. Here this is y0, this is nebula y0, nebula square y0 is equal to 4, nebula power 3 y0 is equal to yn, nebula yn, nebula square yn, nebula cube yn. So in the backward formula, we use the values from the bottom row. Yn is equal to 101, nebula yn is equal to 8, nebula square yn is equal to minus 4, nebula cube yn is equal to minus 1. Find f of 45 for the given data. The same example, solution. Here xn is equal to 50, last term. Yn is equal to 101, and the interval h is equal to 10. The interpolated value x is equal to 45. We need to find f of 45. So u is equal to x minus xn 50 divided by h is equal to minus 0.5. Backward differences are nebula yn is equal to 8 from this table, 8 minus 4 minus 1 respectively. These are the backward differences. Using the formula including the third order term, y45 is approximately equal to yn plus u into nebula yn plus u into nebula plus 1 by 2 factorial into nebula square yn plus u into u plus 1 into u plus 2 by 3 factorial into nebula cube yn. Since we are given 5 arguments, we can use the 4 arguments formula only. Up to nebula cube yn only we can use. Values from the table yn, nebula yn, nebula square yn, nebula cube yn, and u values. Calculate the 4 terms, 1, 2, 3, 4 terms first. This is 101 directly from the table. This is u is equal to minus 0.5 into nebula yn is 8. This is minus 4. Term 3. We need to calculate term by term. U minus 0.5 minus 0.5 plus 1 is equal to 0.5 by 2 factorial is equal to 2 into minus 4, nothing but plus 0.5. Term 4 is 0.0625. Final result is substituting all these values, we can get y45 is equal to 97.5625. Thank you.